Hello, friends. If you've been following along at home, you know that I've been working on this Harris 1 kilowatt operating position using an RF-590 receiver and a remoted RF-1310 exciter. The remote is the RF-7405 and will allow me to operate the exciter next to the receiver in an operating position, and it will allow me to position the transmitter somewhere where the fan noise would interfere less with my microphone as I operate. Generally, things have been going very smoothly, but I ran into some really odd behavior that caused me to then go down quite the rabbit hole to understand what was going on. I should mention that I'm still down that rabbit hole as of this writing, but I've learned a lot about this remote system. In a nutshell, the keying of the system shows significant lag. This lag occurs on both key down and key up. There is also significant delay for PTT, push to talk, on and PTT off. The lag for PTT and key up can be as much as a half a second or sometimes more. For phone modes, this isn't the end of the world, as you can press the PTT and wait a beat before starting to speak. And hopefully the other station won't begin their transmission before your PTT key off completes, given the lag. However, for CW, this is a total non-starter. You simply cannot send anything in CW other than pressing the key just for the purposes of tuning up your antenna coupler or adjusting your output power. Attempting to send anything in CW, a V for example, da, produces just one long da. I'm not a CW operator, so I really shouldn't care about this. But for some reason, it really bothers me, and therefore I began this long descent into madness, trying to attempt to understand what is going on here. First, to correct a few things I said in error in previous videos. Error number one: I had originally thought that in addition to the serial line and audio lines, I had to run key lines. This was incorrect. Running the key lines as separate hardware lines is not strictly necessary. I have learned that the remote will key and unkey the exciter over the serial line, interestingly, and I believe this is the normal mode of operation. I believe it is unusual to run key lines using this as a remote, but I'll explain more about this. This makes sense when you think about this remote being able to remotely key up to 99 transmitters and 99 devices. Since there's only one CW key out signal on this remote, how would you individually address one of the 99 transmitters to only key one of them? And since the serial communication already has an ID as part of the communication protocol for each unit, it makes sense to key the transmitter over the serial line and using the ID to address the specific transmitter. Having said that, there is a benefit to using the external key lines as they will key the transmitter faster, much faster, than doing it over a serial line. A faster baud rate between the remote and the exciter might also help key more quickly over the serial line, but there's still a significant lag. More on this later. Error number two: the CW outline on the 7405 remote does not key both the CW and PTT. In fact, while there is a hardware CW signal line out, there is no PTT signal line out. PTT can only be keyed through the serial interface. So this is important to note. I had incorrectly stated that that PTT key line functions for both CW and PTT. It does not. But I was confused because the PTT line is still being keyed over the serial port, so that is kind of why when I keyed up and I saw it operating, I figured that it was the hardware key lines. In fact, it was not. Okay, so let's look more at this problem in a little bit more detail. The image shown here is from my LaCroix oscilloscope. I'm a big LaCroix fanboy, actually. The first image is showing the keying characteristics without using any hardware lines. So this is strictly keying the exciter from a command over the serial port. Similarly, the key up condition is also shown and there must also be a serial key up command because you can key down and hold it for a while and let it up, and then the transmitter eventually will key up. So there's got to be two different commands there as sent over the serial port. The yellow trace is the CW key output signal from the rear of the remote. What that means is that's the line that I had been connecting to the key lines as a physical hardware key setup. However, in this chart, this signal is not being routed to the exciter in this particular case. So what we're showing here is purely a software serial line keying scenario. But it does tell you, that yellow trace does tell you something about when I had intended the key to actually go down versus where it ended up going down because of the serial communication. The red trace is showing the status of the transmitter's actual key line. This is the real-time representation of when the transmitter is actually putting out RF during a low condition. And you can clearly see the lag both in the key down and the key up. Okay, in this next slide, I've enabled some cursors to measure the lag. You can see the measurement in the bottom right of the screen capture where the red box is. So this lag is not consistent, but in this particular example, you can see a key down lag of about 240 milliseconds or a quarter of a second. Again, it can be more, it can be less, it's inconsistent. Similarly, the key up command also has a significant delay. Here I move the cursor to the key up part of the waveform, and you will see about 180 milliseconds, again, not consistent. I've seen cases up to 500 milliseconds or more on occasion. Regardless, this is totally unacceptable for CW and unusable. Okay, so the fact is that the situation is even worse than this oscilloscope trace would have you believe. And the reason is because I had been measuring the key out signal from the remote and then comparing it in time to when the transmitter actually was transmitting. But what I hadn't been doing, and I do this a little later in this video, is I can show where the key down is actually occurring from my fist, right? So I'm keying down on a CW key, but what I'm showing here is the output of the remote. And what I will demonstrate a little later is that there's even more delay when you start from when the key is actually pressed to when the key out yellow trace displays. So the situation is even worse than this would suggest. Okay, so I believe that the designers of the system realized that serial command-driven keying is totally unworkable for CW, and because of this created a separate hardware signal for it intended to be routed to the CW key input of one exciter. I say one because there's only one CW signal out, and well, I have already discussed this issue. I also believe, as my friend KB2VTL suggests, that at the time the system was designed, CW was either already being phased out for use in places like embassies or possibly shipboard, and therefore I don't think these issues were big enough for them to thoroughly solve. Or at some revision level of firmware, perhaps a bug got introduced and then nobody noticed it because no one was using CW in a remote installation. That's entirely possible too. As potential evidence of lack of importance of CW for this system, the exciter itself has no quarter-inch phono jack for a key, and the U229 connector on the front of the exciter also has no contact signal for a CW key. This is in contrast to all of the Harris tactical radios that I have that have both the PTT and CW key contact on their front panel U229 connector. In fact, if you want to run the exciter in CW, you need to tap into one of the DB37 connections on the rear. This to me indicates a serious sort of demotion of importance of the CW mode in this family of radios. I mean, think of having to connect into a DB37 just to get one signal out to run a CW key. But very interestingly, it seems the 7405 remote has a slightly higher opinion of CW than the exciter has. The 7405 has a standard bona fide quarter-inch phono jack for a CW key, albeit located on the rear of the unit. And even more interestingly, the 229 connector on the front does indeed support a CW key in the same way as the tactical radios do, and you can use a tactical key like a leg key or something like that, and it works just fine. Having said all that, as I will continue to show, I still cannot fathom how on earth this mode can be used with the 7405 remote, despite having some CW capabilities. And this is really what makes this a mystery. It's just a complete mystery why they would go through the trouble of having some CW features and yet the implementation of it be completely unworkable. So I mentioned earlier that there is a CW key out signal from the remote and a CW key input to the exciter. I thought for sure this would solve my issues and everything would work as expected. Here is a similar waveform showing the response. Okay, so once again, what I've done is in this diagram, in this printout, I'm actually using, I'm connecting the key out signal from the exciter to the remote, essentially foregoing the software keying as best I could and attempting to use hardware keying. And what you can see here is that the key down delay is now gone, meaning that the exciter is being keyed from a hardware signal from the 7405. However, the key up signal is still not being recognized to unkey the exciter. And you can see in this particular case that the key up delay is nearly 400 milliseconds. Herein lies the fatal flaw of this design and why I believe the system, although it has features to support CW, cannot actually be used in this mode. Before we continue on with more analysis of CW, I wanted to show that the same issue occurs with phone modes and the PTT control on the mic. And so while the exciter does have a separate PTT key input line, unfortunately there is no PTT key output line on the 7405 remote. Therefore, we must live with the delay on both key up and key down for use in phone modes using a PTT. So here you can see that there's about a 225 millisecond delay on the PTT close, meaning key up, key the mic. Yeah, and you can see a whopping 474 milliseconds on the PTT open, letting go of the mic, finishing your transmission. So luckily in phone modes, this is not a deal breaker. Pressing PTT and waiting a beat or two before speaking is perfectly acceptable. In fact, if you really want to be sure the transmitter is keyed, you could also just look at the key indicator on the remote and wait for it to illuminate. This is a full feedback system, meaning not only have you requested the key, but the exciter is reporting back that the key is actually asserted. Okay, so let's go through why I believe the behavior is what we're seeing. So let's take a look at the keying schematic of the 7405 remote. So first, it is important to note that the CW, the actual CW key that you have in your hand, does not connect directly to the CW key out signal that goes to the exciter. Instead, it forms an interrupt, essentially through this circuitry, it forms an interrupt to the microprocessor. And likewise, the CW key output signal is not a direct result of the physical key, but instead is an output of the microprocessor. So let's look at the purple trace in the diagram. I have it annotated as CW, as front panel CW and rear panel CW, and they merge together at that point. These are the lines that are physically connected to the CW key. And you can see them entering into a chip, an input port IP3, pin IP3, of this 2681 UART, Universal Asynchronous Receiver Transmitter. But before they enter, they go through an inverter gate, and this inverter gate has a pull-up resistor of 100 k ohms and a filter capacitor of 3.3 microfarads. Presumably, this is to reduce the effective key bounce. More on this just a little bit later. So while this chip is a UART, in this case we're not using it for any serial features, but the chip has one general purpose 8-bit input port and one general purpose 8-bit output port, IP and OP. Similarly, the front panel push-to-talk line is the green line coming in from the left here, going into IP2 of the chip. IP2 is bit 2 of the input port. And like the CW key line, you will also see an inverter with the same pull-up resistor and filter capacitor. So interestingly, on this chip, you look up the specs, IP2 and IP3 both have a special feature that will detect a state transition and initiate an interrupt to the CPU. The other bits are basically just pulled, but this will generate an interrupt. And as you can see, the interrupt line in pink from the IRQ pin of the UART going to the programmable interrupt controller chip, or PIC chip, the 8259A, and that finally will interrupt the processor based on some priority that it defines. And finally, looking at the blue signal, there is an output port on the UART, OP7, which is bit 7, that runs through some buffering transistors, and this goes to the key out signal on the back of the remote. And this is the signal that connects the rear of the remote and what is ultimately connected to the exciter if you choose to hardwire the key lines. Armed with this understanding, I did a little more exploring and looking at the various causes of delay. In an effort to eliminate this delay as much as possible, I set the system up to use physical key lines of the exciter. This means that the CW key out signal of the remote is going to the CW key in on the exciter. As we discussed earlier, this eliminates the lag on key down. So here's another screen capture of the scope. So let's go through it. The top blue trace is the physical CW key line signal that we saw going into the inverter. We saw this earlier on the schematic. The next green trace is the output of the inverter, which forms the input to the input bit on the UART. So that's the earliest that the UART is going to know that somebody has requested the CW key. The yellow trace is the output bit of the UART, which goes through the transistors and out the rear of the remote, ostensibly to the exciter. And finally, the red trace is showing when the transmitter is actually putting out RF, the key line out, just as we discussed before. Let's go through this a little bit more. So the first thing you'll notice is when the CW key is down, there are no delays anywhere in the system. The system responds instantly. That's the benefit of a hardware key line, and this is great. The first delay we see is on key up. Here you can see the telltale RC time constant curve of a resistor and capacitor in series. We mentioned earlier that there's a 100k ohm resistor and a 3.3 microfarad capacitor essentially in series from 5 volts to ground. Here you can visibly see the results of this, and if you look at the green trace, you can see that the output of the inverter, which forms the input to the UART, is delayed a full about 200 milliseconds. This is the first problem with this keying system. For a good CW operator, one who does 20 words a minute or 30 or 40, or some guys even do 50 or 60, I think a delay of 200 milliseconds would be difficult, probably impossible to deal with. So this is the first problem. I think maybe if I were designing this, I might use a pair of flip-flops I think that's how you do it, I've forgotten already, to form a debounce, a key debounce circuit, as opposed to using an RC filter. This is the decision that they made. But what you can see here is the real killer is how long it takes for the exciter to realize that the key has been released. Here you can see about an additional 300 milliseconds of delay. So taken together with the previous delay, the system has taken a full 500 milliseconds or half a second to realize that someone has let up the key. In my opinion, this is a total fail. Not something I typically or maybe have ever said about Harris equipment. So why does everything behave the way it does? I think the system is first being keyed by the hardware line. This explains why on key down, everything is instantaneous. Next, while the key is still down, the UART recognizes that the key's down and goes ahead, interrupts the CPU, and sends a software version of the key down signal over the serial line. Now, this software command, the serial command, has no immediate effect because the transmitter is already keyed from the hardware lines. However, the exciter CPU must have a state machine and know that it is now in sort of software key down mode, key down state, etc. So next, the user releases the key, and the hardware line returns to normal. However, the software state in the exciter, the state machine in the exciter, is still in a key down state because it's waiting for a key up signal over the serial line. And therefore, the hardware key up really has no effect on the keying. So here is a logical representation of what I believe is occurring in the system. I'm sure there is no actual OR gate that I've drawn here, but this should give you an idea. Because the software takes time to send and receive the command over the serial port, then a little time processing by the exciter CPU, etc., it takes time to deassert its line. And if you think about it conceptually as a logical OR between the physical key line that it has and the serial key line signal, a command such as key up, whatever. As you can see, when the key is released, the software key has not yet changed state, and therefore the overall key line is still asserted. Okay, so what am I going to do about all of this? I've made a modification to the rear panel. This modification adds a 1/4-inch phone jack for a CW key to the rear panel. Now, the way I'm having this work is it connects directly to the exciter key lines and completely bypasses the 7405 remote entirely. You can see the jack here that I'm pointing to with a pencil. The idea is that I'm eliminating all of the software of the 7405 and the delay it represents, all the serial line delay it represents, the key bouncing, filtering that represents, and I'm just going completely direct key up and key down. And doing this, it gives me full, super responsive, full QSK keying in this system. It works because by bypassing the remote never knows that the CW line has even been asserted, never sends a serial command to key down, and therefore there's no reason to ever send a delayed serial command to key up. And therefore I avoid this issue entirely. And it works very well, as I will show you now. So this is, I'm going to show the improvement of the CW keying in this new method. So, as I mentioned before, I bought this, I replaced this rear panel. The original panel only had 6 ports in it, 1, 2, 3, 4, 5, 6. And to do what I wanted to do, I was going to need a CW key port. And while I was at it, since they make these in 8-port variations, I decided I'd also put the RS-422 signal accessible here rather than going all the way into this enclosure here to plug it in from the transmitter. I would just make it nice. It just makes for a nicer installation, I think, to have all the external signals available on one panel, and I like that. And so here's that CW key. Let me show you what I've got. Just take a quick look at the remote setup. I don't have anything else installed at the moment. So I've got it on CW. I've got a very low power, minus 10 dB from 1 kilowatt, and some random frequency. And up here I've got 2 keys installed. This first key plugs directly in to the rear of the remote here. And that key, because it's going into the remote, will go through the entire software and firmware and serial communication scheme. And then this one, forgive the jumper here. This one is plugged directly into here, which is a direct connection to the exciter key lines, bypassing the remote altogether. And so what we're going to do is we're going to look on my little station monitor here in a sort of a scope mode, and we're going to take a look. I'm going to attempt to send with my left hand a V, a Morse V here, and then we'll do a Morse V here. And let's see if we can get this going. So the first thing, let's start up the amplifier. Let's start up the transmitter. We're going to standby mode. Okay, let's go into operate mode, and you'll hear the fan spin up. You can hear it over there. Okay, so the first I'm going to use this key. This goes through the remote and goes through all the software and serial line, and I'll attempt to produce the letter V, and you'll see it here. Ready? V is di-di-da-da, 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 etc. So you're really only seeing, you see the initial key up, but one big block of time, one big block of transmit. Now we're going to use this key, which is connected to this new port I made here, jack, that goes directly to the key lines, and let's see what we can do. Da-da-da-da, 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 da-da-da. So you can see the dits, whereas before you couldn't see them. Going back to the remote CW key, nothing, just one long thing. And then finally, one last time with this key going hardwired to the key lines. And this is showing RF output, so you can see it's actually working as expected. Yeah, and so that's it. And finally, I decided to go with a 2U panel instead of a 1U. It gives me a little more room to put my labels and just a little more room to work. All right, well, that is it. That is the final video, I think, on this 7405 remote control. There will be other videos talking about routing audio around the shack, but I think this is it for this. Well, this brings us to the end of this video. I originally considered looking more detail at the interrupts of the CPU and the serial communication to further delve into this issue from a software perspective, but alas, cooler heads prevailed. Going down that route might have been academically interesting, but ultimately I have things working very usably now. I understand the issues and why they happen, and I've pulled out enough hair for one video. I think I could live with a short delay in PTT keying, which is my most common mode of operating, and for CW, bypassing the remote entirely gives me the full QSK keying on a mode I don't even use. So that's it. That's a wrap. Thanks very much for enduring yet another video, a little bit more theoretical than practical, and I hope you enjoyed it. If you didn't, let me know. Either way, please subscribe. Thanks.